Here we are in KCSE question number 20, paper 1, 2017. Okay, we have a quadrilateral ABCD. DA, we are given it as at 3 centimeters, AB as 11, BC as 8, and AC as 5 centimeters. As 5 centimeters. Okay, now we are told to calculate correct to 1 decimal place the length of DC. The length of DC. Alright, so the length of DC. So when we look at this a figure of ours, it is a four-sided figure which is subdivided into 2 triangles. And we are told that DAC is a right-angled triangle. So we can have our DAC here. We have our CAD, that AD is 3, that AC is 5 centimeters. So now we are looking at, we are supposed to find the length DC, Okay, and we are told that this angle of ours here, that is angle DAC, is 90, or right-angled triangle. So being a right-angled triangle, we can use the Pythagoras theorem for us to get the hypotenuse, or the longest side. So we can say that CD squared is equals to AC squared plus AD squared. So here we have our AC will be having 5 squared plus a 3 squared. So this one is going to give us 25 plus 9, giving us 34. So 34 is the CD squared. So what about CD? We have to find the square root of 3.4 and get it at 5.8 centimeters. So we have this side here as 5.8 centimeters, or here at 5.8 centimeters. All right, just simple, to 1 decimal place. Number B, we are told to find the angle. Let me see, the size of angle ADC. Angle ADC. And this is the angle which is here. So now, there's a secret that you need to know. Whenever you are given a question and the examiner have given you some of the dimensions of that particular question, please use the measurements that the examiner has given you to avoid any kind of errors, or maybe transfer of errors, because like in this example of ours, we can make a mistake somewhere. But now, whatever the examiner has given us, it is very accurate. So we are not supposed to use the sides that were given by the examiners. If the examiner had not given us the measurements, then we can use the other measurements that we have found, making sure that we are very careful in each and every step of our way. So now from the SOHCAHTOA, finding sine, we have to use the hypotenuse and even on the cosine, and it is the one that we are trying to avoid, since it has the side that we have got ourselves. Yes, even if we use it, we are supposed to get the same answer, but for us to be very much careful, it is advisable to use the measurements that the examiner has given us. So now for us, now we are going to use the tan. Tan is convenient for us. So we have tan, we can have it as alpha. It will be equals to opposite over adjacent, TOA. So opposite, which is 5 divided by 3, alright, like that. And that means now we are going to have our alpha as 59.0 degrees. That is the angle that we have. Remember, it is 1 decimal place. So it is okay, it is advisable to put a 0 to ensure that it is to 1 decimal place. I hope you have got that. So let us move to the next question. Question number C. Okay, number C reads, we calculate the size of angle ACB. ACB. So on this kind of a triangle now, when we check here, this angle, it is more than 90 degrees. If this one is 90 degrees, then this one is more than. Remember, it is not drawn to scale, but it is also advisable for us to use the common sense in this kind of a topic that we're supposed to have the common sense. So now let us see how we are going to go about this. So here we have A, C, B. We have 11 on this side, we have 5 this side, and we have 8 on the other side. So now for us now to get this angle C, we have to say 11 squared is equals to 5 squared plus 8 squared plus 2 times 5 times 8 cos C. Remember, we using the cosine formula. I remember I had talked about it in my previous video. So now this is the cosine formula that we have. So we can bring 5 squared and 8 squared on the other side of the equal sign. So here we have 121 minus 25 minus 64 is equals to 80 cos C. So when we subtract this one, we are supposed to get that 2 is equals to 80 cos C. Divided by 80. So here we'll be left with the cos C. We have cos C being equals to 0.4, meaning our angle C is going to be 66.4 degrees. Right, 66.4 degrees. But now, as I just mentioned, this angle, it is more than 90. Just by the look, it is more than 90 degrees. And so now we cannot have our angle being 66.4. Rather, we are going to use the information that we had learned earlier about the unit circle. The angle is, we have another angle which is on the second quadrant, which is equal to 66.4. And for us to get it, we are supposed to say 180 minus 66.4. Then we are going to get 113.6 degrees. And this is what we are supposed to have. Remember, we cannot have the angle which is on the third quadrant, because this angle here, it is less than 180 degrees. And if we go to the third quadrant, the angle that we are going to get there will be more than 180 degrees. So we have to apply all those concepts that we had learned at the beginning of our topic. I hope it is clear to you and that you can follow all through from the very first to the end. So I want us now to look at the last part of that question, that is number D. Number D. Okay. Number D reads the area of a quadrilateral ABCD. So we have the first triangle and the second one. Everything here is going to, when we join the two, we are going to have that quadrilateral ABCD. So now it is wise for us now to divide the two. So here we have the first triangle and the second triangle. So let us first find the area of the first triangle. We have half times base times height. So here we have half multiplied by the base, which is 3, times the height, which is 5, and it is going to give us the area of 7.5 centimeters squared. All right, let us check about the second triangle. When we look at this, these are two different triangles, and we cannot have the same formula. We cannot have the same formula, but our methods must give us the same answer, or rather the correct answer. So here we have half multiplied by 5 multiplied by 8 multiplied by sine. The angle here that you have just got, which is 113.6, or we can also put 66.4. Remember, we said all students take care, so the answers are going to be the same. So when we calculate this one, we are going to have our answer as 18.3. So now for us to have the area of the quadrilateral ABCD, we are supposed to add the two areas. That is 7.5 plus 18.3. So 7.5 plus 18.3, we get our answer as 25.8 centimeters squared. Remember to give our answer to 1 decimal place. And that is how now we get the 10 marks from a very simple question. Don't forget to subscribe to my channel. Thank you.